This is the Building Automation Monthly Podcast with Phil Zito, episode 191. Hey folks, Phil Zito here, and welcome to episode 191 of the Building Automation Monthly Podcast. And depending on when you're listening to this, welcome to 2020. This is our first podcast of the new year, I believe, if I'm counting my days properly. So in this episode, we're going to be talking about how to troubleshoot IT systems. You know, IT systems tend to really throw a lot of folks in the BAS industry for a loop, but with the introduction of IP-based controls, with all these analytics systems, with cloud-based building automation systems, we're running into an increasing need for us to have the capabilities of troubleshooting IT systems. But how do you approach troubleshooting IT systems? It can be pretty complicated for a lot of reasons. And so in this episode, we're going to be talking through my IT troubleshooting process. We're going to look at a couple different scenarios, talk through how those were troubleshot. We're going to look at kind of how you can ask questions before you're troubleshooting to really figure out what the issues are. And we're just generally going to look at IT troubleshooting overall and get some best practices in place and really some mentality and thought process in place of how to think about troubleshooting IT. This week's episode is brought to you by our Information Technology for BAS Professionals course. If you are looking to learn information technology, let's say you're a building automation technician, you're in sales, you're a project manager, you're an engineer, and IT is something that is just a stumbling block for you. You're having trouble working with customers' IT groups. You're not making your sales because IT is disqualifying your solution. You're running into delays on your projects because you just can't get IT to work with you. Or maybe you're having trouble setting up all the aspects of IT required in order to get a modern building automation system up and running. This course will handle all of that. By the time you finish this course, you will know everything you need to know about information technology to effectively sell, project manage, install, and operate a building automation system. So if you're looking for that one-stop shop to teach you what you need to know about information technology, this course is it. This is what you want to enroll in. So go to buildingautomationmonthly.com/191 and enroll in the course and learn IT and start off 2020 with a solid foundation of information technology skills. All right, so let's dive in. Whenever we are troubleshooting IT, we've got to start off by solving a problem. I mean, that is in itself what troubleshooting is all about, right? We need to figure out what a problem is, and then we need to solve a problem. Where I see a lot of folks get IT troubleshooting wrong is they become very reactive when they start to deal with technologies they're just not comfortable with. I tend to find when folks are troubleshooting electrical systems or mechanical systems, they have a very defined process. They go and they look at specific parts and pieces in a specific order, and they use a troubleshooting methodology where they go and actually find out from the customer what's going on. But then you see a lot of folks out in the field, and I myself have been guilty of this before, where we can't get something to work and it's a technology something. Maybe it's a protocol, maybe it's a network, maybe it's a server, and we're trying to get it to work, and we just keep going and changing settings until finally something works. And if we're honest, if it's just you and me here, and we're being honest with each other, there's a good amount of the time that we really don't even know what we changed to make it work. We just start changing settings, and eventually it works, and we're like, don't touch it because it's working now, and we don't want it to break. But we don't know why it wasn't working in the first place, and we don't know what we did in order to make it work. So whenever we look at IT problems, we need to approach them from the same perspective of troubleshooting mechanical or equipment or electrical. So when we're thinking about that, right, what would we first do if we showed up at a site? Well, we would start off with some basic troubleshooting questions. We would start to think about, when did this work? And when did that all change? When did it stop working? And does it not work all the time, or is it only working part of the time? So let's say you show up at a site and you have an issue. Maybe you have a supervisory device that sometimes is online, sometimes is offline. When you show up there, you would want to ask, when did this work last? Has it been consistently down since that time, or is it up and down at specific times? The reason you're asking these questions is you want to be able to really figure out what is going on. And when you're dealing with technology, it's oftentimes not something you can take a multimeter to and just, oh, I've got continuity or I've got voltage here. Oftentimes it is something in software, it's something in settings. And because of that, you have to frame the problem. The concept of framing the problem is where you essentially put boundaries around the problem. So for example, if you realize that this device is normally working, but at nighttime for an hour, it goes offline. Okay, that gets you somewhere because now you can start to frame the problem. You can start to frame when the issue is happening. There's no use troubleshooting something during the daytime if you realize it's failing at nighttime. Now, I know that may seem very simplistic, but when you start to get into protocols, when you start to get into working with cloud services, you can start to frame individual softwares. You can start to frame the protocol. For example, with BACnet and BBMDs and BDTs and BACnet networks, if you know that you're able to communicate with one BACnet broadcast domain and that's working great, but you've got another broadcast domain that's not working, then you can frame it and you cannot sit there troubleshooting the BACnet network that is working, but rather troubleshoot the BACnet network that's not working. On the inverse, you can look at the BACnet network that is working and look at the one that's not working, and you can do a comparison. So it's really important that you frame the issue with these pre-troubleshooting questions. What we're primarily looking for with those questions I just asked, which is when did it last work, what changed, and does it fail all the time or is it periodic, is we're looking for state change and situational failures. We're framing our problem. From there, we move on to the next set of questions I see a lot of folks not ask. And this is especially damaging when doing IT troubleshooting because, as I mentioned, oftentimes we're sitting there just flipping switches and changing settings. Hey, maybe you all don't do that, but I mean, I'm a pretty smart person. I'm not to toot my own horn, but I'm really good with technology. And even I find myself sometimes just changing things to try to figure out what's going on because there's so, especially when you get into APIs and integrated systems, there are so many interlocking layers that sometimes you just got to change stuff and see what happens. However, now we're looking at what did other people change. So when you show up on site, what have you done? You ask that to the people who are on site. What has been done? Who has worked with it? What have they worked with? Has anything happened in the building? Was there construction? Was there a software upgrade? What changed? So our first set of questions was framing the situation. We were figuring out when does this happen and why, or well, not why, but when. Now we're looking at what has changed. These all are giving us input. So for example, if we find out that IT just rolled out a software update to all the servers and all of a sudden our legacy BAS software is no longer running, that gives us a pretty good idea that yeah, it's probably a compatibility issue, and we go troubleshoot. If we realize that an IT group just switched from static IPs to dynamic IPs, and now a bunch of our devices are no longer communicating, that also gives us an idea of what may have happened. So what we have to do is we have to figure out kind of what could be affecting things. From there, we move into a 4-step process. Step 1 is to identify changes. We want to figure out what has changed and how has it changed and what change can we control and what changes probably have no effect. This is one of the most difficult parts of troubleshooting is identifying what changes happened and what changes actually impact things. So for example, if we're having issues with a BACnet IP network, and I tell you that someone went and upgraded a server and the BACnet network no longer works, what would you be thinking? What thought processes would be going through your mind? If you started focusing on IP addressing and the networks and things like that, that might be true. That might. But the likelihood of that being the core issue, the network being the core issue, is probably slim. Now, how could that server upgrade be affecting the network? It could have simply been, hey, they changed the IP address on the server, and now it can no longer connect with the BACnet network. What more likely is going on is that changing that software on the server probably disabled, a BDT or a BBMD, no longer allowing you to communicate with the BACnet network. So you've got two potential issues there, and you can troubleshoot both. But you have to identify the changes in order to even get to that point. Once you've identified the changes, we can move on to step 2, which is define the situation. I just want to pause for a second because if I'm feeling this, I'm sure you all are feeling this. I know this seems pretty obtuse right now. It's pretty kind of vague and just conceptual. Don't worry, we're going to go through scenarios where we actually apply these steps in a troubleshooting environment or situation. And I'm like, how can we apply an environment over a podcast? That'd be interesting. But no, we're going to apply this troubleshooting approach to a couple real life scenarios that I've been through. So if these steps are just kind of conceptual to you right now, don't worry. I promise you they will make a lot more sense as we start to move through the 3 scenarios later in this podcast. So next we need to define the situation. We need to define exactly what's going on. We identified what changes are happening. Then we need to define what's going on. Are we having network loss? Are we having software down? Are we having connectivity issues? What is going on? We need to define that. Once we know what the situation is, we need to isolate the physical and logical variables. So the physical variables would be things like the network, switches, ports, etc., right? Server running, those kind of things. Logical variables would be things like settings, port numbers for BACnet, BBMD, BDT settings, IP address settings, all of that jazz, firewall settings. Those would all be logical variables. And what I like to do, and this is a very advanced technique here, and it's not for everyone, and if this is something where you have like any doubt of your IT capabilities, I don't recommend you do this, but something I like to do is I like to look for parity. What that means is I look for the exact same piece of equipment or something that I've seen at a different job site that would be considered parity. So if I have a VMware server running a virtual image of a Johnson Control software at a specific version on a specific subnet type, I can look for parity and say, okay, I have pretty much the exact same system on this job site. What is different? So what is different between these two? That's why I said it requires an advanced knowledge of IT, because you need to understand all the potential settings that you could be running into. But if you understand that, then you quite simply can go and look at, oh, I've got this up and running, and here's the settings. And then, oh, I've got this up and running, and here's the settings. This is the difference between the settings. This isn't always going to work. Sometimes it can actually cause more confusion. That's why I said you got to be careful with this one. But it is really helpful in troubleshooting. I've used it quite a bit. And then finally, you need to choose whether you're going to work up or down the stack. What do I mean by that? If you've been listening to this podcast for any amount of time, you've heard me I can't even say the word. You've heard me describe the concept of the stack. Is that how it's going to be this new year? I'm going to struggle on podcasts saying basic words. I don't know. That was interesting. I haven't had that happen in quite a long time where I just total loss for words, but whatever. Anywho, as I was saying, we're going to work up or down the stack. And what I mean by that is this concept of the stack is that you have a physical network, and then that moves into switches and routers, and then it moves into machines and software and settings. So you have this stack of technology. And by working up the stack, you start at the most basic area, network connectivity, and you work your way up. Working down the stack, you start at the software and you work your way down. So if you had a building that had 4 supervisory devices, and one of the supervisory devices had a backnet network that was down, you could start at the top of the stack at that supervisory device and work your way down the trunk, figuring out, is this an electrical issue? Is this a setting issue, etc. On the flip side, if you had a site that went down for whatever reason, you could start at the bottom, just making sure, hey, when I say this, you're going to laugh, but am I connected to the VPN? Is the internet in my office on? Because I've had people who literally, customers call me, I can't access the building automation system. It's not working. The building automation system's been down for 4 hours. And I'm like, well, I can access it from my computer. And they're like, well, we can't access it. Turns out the internet in their office was down. So starting at the bottom, which is the internet, I asked them, hey, are you able to connect to the site? Well, no, I said I wasn't able to connect to the site. Okay, well, how do you know you're not able to connect to the site? Well, I can't get the VPN to connect. I'm like, okay, well, that doesn't necessarily mean the site's down. That just means the VPN can't connect. So then after going through that, the VPN, I said, okay, well, can you access a website? Well, no, I can't access a website. I'm like, can other people in your office access a website? Nope. Well, then you figure out the internet's down the office, and that's obviously they can't VPN into something if they have the internet down their office. I mean, kind of basic, yes, but you can start to see where me starting to troubleshoot at the server would not have made a whole lot of sense. It would have been a ton of wasted effort. I really hope that that makes sense to you, because if it doesn't, my fear is that you'll spend a lot of time troubleshooting things that you don't need to troubleshoot. So let's take a look at a couple scenarios that I ran into throughout my career that had stumped quite a few people, and through misfortune or whatever, I got brought in to go and fix the issues. The first was a data center issue. It was having periodic failures, so that's right there, right? That's when was it failing? Periodically. But were these periods constant? Were they variable? What was going on? Well, they actually were the same time every night. And so, okay, we know when it's failing, but how is it failing? How do we determine this? Well, it was a supervisory device at a remote site that would go offline. We could see all the other sites, but we couldn't see this one site from the server. It was going offline. So you can already tell right there, we're starting at a working down the stack approach. We're starting at the server and we're working down to the site. So we started to say, okay, what could possibly cause that machine to go offline? Well, we know that the physical system could have went off, right? We know the network could have went off. We know the services connecting to it could have went off. So we put a log on the actual supervisory device, and we were able to see that it never went down. The supervisory device at the site was not going down. So we knew the supervisory device itself was not going down, which then says, okay, the physical system is fine. We also know that the services on the server that the supervisory device would connect with were up and running. So that narrowed it down to the network. And at that point, we started to say, okay, how are we going to determine that it's a network issue? And we started to go and check the network side of the main server. We started to branch out from that. We were able to connect to the site through the network using ping requests. So we weren't losing the site. But as we started to analyze data traffic, we started to see that very few messages from the building automation system were reaching us at the server. So very few messages from the supervisory device were getting to the server. So the remote site wasn't getting through. So we said, okay, where is this point of failure? And we started working with the IT group to determine at what point. Basically, we figured out that at a switch, they also had a bunch of data update for database backups from unrelated business systems going across the trunk. And that trunk was using quality of service, and that quality of service of that data traffic for the backups was higher than our BAS data and was causing the BAS data to essentially get dropped at the switch because the switch is going to let the highest quality of service data through and drop all the rest. And that is where our supervisory device offline was coming from. It was really difficult. It took folks a while to figure out exactly what was going on because it was insidious, especially when we determined that we could ping the supervisory device. So we thought for the longest time it wasn't the network, because obviously it's not the network. If we can ping it, it's got to be something with the server and the supervisory device. When in actuality it wasn't. It was simply a quality of service issue with the switch, which brings up a whole nother topic of how do you determine that if you can't even log into the switch and run the reports, which is why you need to understand some of the words that I'm using here. If you're not understanding the words I'm using here, I really recommend that you learn them, because you won't be able to communicate with an IT group in order to converse about the issues you're experiencing in order to have them help you work through them. So the next issue I ran into was a BACnet integration. So this BACnet integration never worked, like literally never, from day one. How they got their retainer and got off the job and all that, I have no idea. But it never worked. There were no changes made. And so we have to say to ourselves, all right, we're going to do parity here. This was a Lutron lighting system. What makes BACnet work? Right? There's really kind of two things that make BACnet work. Common settings, so your ports, your network numbers, your device instances, all of that jazz, right? And your physical setup, making sure you actually have a network that can work. We decided to take the bottom-up approach, the physical network. We checked the physical network between the Lutron server and the supervisory device. Everything was good, was communicating. Heck, we could even see BACnet traffic going to the switch and going to the router. But for whatever reason, it was not going and getting to the server. Now, the thing is that when I tell you this, you're going to be like, man, that's an obvious, easy problem. And you're probably already thinking of what the problem was. Thing is that there were so many other networks at this one site that folks never thought to look for this. So as we started to go through the physical setup and realizing that the physical setup was fine, we started to go through the settings. And that's where we discovered the issue. We looked at another site that had a server and a Lutron system working just fine. And what we noticed, device instances, because this was based off a standard, device instances were the same, settings were the same. The only difference was the port, 47809 instead of 47808. This port mismatch was causing the BACnet communication to not work, and even though we saw the BACnet traffic going through because the BBMD and the BDT were set up properly, we were not seeing the ports communicating, and we were not seeing the BACnet traffic actually happen to, we were seeing the BACnet traffic. We weren't able to connect the BACnet devices. So we changed the port on the Lutron system from 47809 to 47808. Everything worked just fine. This was insidious because we were able to see the BACnet traffic on the server side, but we weren't noticing that it was a different port. It's just attention to detail, I guess you could say. And so because of that, it was having an issue. And from here, let's look at a third issue, one that hopefully you all don't run into, because this one consumed, I think, like 6 months of my life. And it was really interesting. So I was working for a manufacturer, and they had some software, and it was at a hospital. And the software would fail periodically. It was on a touchscreen, and it would just fail. And it failed kind of randomly. At least we thought it was randomly. It definitely appeared random. in the beginning. And it wasn't until the very end that we discovered that it wasn't random. But it did not seem to fail at any particular time. It just failed. So we had to ask ourselves, because at this point, it's like, all right, the software is running on a touchscreen. It's failing at the touchscreen. So it's not a up or down, really. It's just, where does this work? We had to say, okay, well, where does this work? And we found some sites where it worked. What was different? Well, they had the same touchscreens. The difference was the operating system. And so we noticed different operating system. And we had to say, okay, but it's still software, and it's still Windows software. It should run just fine. And we started to look at it. We started to look at the software. The software seemed to be running fine. And it seemed at the time to be an issue with Google Chrome, right? And so we're like, okay, we're going to go and roll back Google Chrome. Maybe it's a version issue with Google Chrome, which it wasn't. The issue still failed, or the software still failed, and we're still troubleshooting. So at this time, you can see within the actual device, we're using a top-down approach. We're starting with applications and working our way down into the core code of the actual operating system. So continued to troubleshoot, continued to try to figure out what was going on, started to debug Chrome, and realized that it looked like a memory issue. So now we put a bunch of logs on the computer, and we started to log the computer's resources. And sure enough, we were having memory leaks. And so we started to figure out that after figuring out what was causing the memory leak, the service that was causing the memory leak, we looked at the all-trusty Google and realized that this specific service in this specific operating system had a conflict. So nothing that would have kept the application from starting, nothing that would have in a test environment went and caused a failure. Because the thing is that the only time this failure would show up is if you're on a site with a lot of data and it sat for a significant amount of time. That's when the failure would happen, because eventually the memory issue slowly would build up and cause the system to crash, and you'd restart it and clear the memory issue. So this was something that was not caught by the manufacturer, and in their defense would have been very difficult to catch. But yet we troubleshot it. And this is, why do I tell you this? Why do I take you through a scenario of software in a hospital that's not really BAS software? Why do I tell you about this? Because a lot of you, and I know this because we work with so many different companies, are looking at becoming master systems integrators and doing complex system integration strategies and really starting to integrate business systems and all sorts of systems into the building automation system. As you do that, you're invariably going to run into conflicts between software. And these are going to be conflicts that not only are not going to be caught by manufacturers, but honestly can't be caught, because so much of our system integration work, because of how immature our industry is done in the field. It's literally field engineered. And because it's field engineered, the test process behind actually going and creating these integrations is minimal at best. So you're going to find yourself in scenarios where software and systems conflict, and you're going to find yourself having to do this form of troubleshooting. And if you can't have these kind of stories to fall back on to see how someone else in your shoes thought through these processes, then you're really going to struggle. So my hope for you coming out of this episode, I know this was a little bit of a different episode, very conceptual in nature, but my hope is that you coming out of this episode, you're leaving it with kind of a thought process, a way of thinking that you can think about how all these systems and variables interact with one another and use a organized, structured process to figure out why issues are happening on sites. So there you have it, folks. My approach to IT troubleshooting. It's so great to have you here in 2020. I'm so glad you're here. Don't forget, I will be speaking Tuesday at AHR And I'd really look forward to seeing you in my session. There will be a link to my session at buildingautomationmonthly.com/191. It'd be great to see you there. It also looks like I may be speaking at the Niagara Summit. I'll know more in the next week or so. And if so, I'd look forward to seeing you there as well. Thanks so much for being here in the podcast. Be sure to go to buildingautomationmonthly.com/191 to check out the notes as well as links mentioned in this episode. And I look forward to talking to you in next week's episode. I think we'll be going through APIs. Maybe we'll talk about networks some more. I really want to focus a little bit on IT for a while. I just got out of the HVAC wastelands for the past 9 episodes, so I'd like to go back to my technical roots. All right, folks, it was great having you here. Thanks a ton, and I look forward to talking to you again next week. Take care.